Searching with partial observations, often referred to as partially observable Markov decision processes, POMDPs, is a fundamental concept in AI. POMDPs deal with decision-making in situations where an agent doesn't have full information about its environment. These environments are characterized by uncertainty, making traditional planning methods insufficient. Instead, POMDPs use probabilistic models to reason about the agent's beliefs over the possible states of the environment. Algorithms like the belief-desire-intention (BDI) model and particle filtering are commonly used to address POMDPs. They enable agents to make decisions based on the most likely state of the environment given the available observations. Here are some short advantages of searching with partial observations, along with brief explanations. 1. Flexibility in uncertain environments. Partial observations allow AI agents to make decisions even when they don't have complete information about their environment, making them suitable for real-world scenarios where uncertainty is prevalent. 2. Optimized resource allocation. By incorporating partial observations, AI systems can allocate resources more efficiently, focusing on areas where information is most needed or likely to yield valuable insights. 3. Robustness to noise and imperfections. Partial observations help AI systems tolerate noisy or imperfect sensor data, enabling them to make reliable decisions even in challenging conditions. 4. Adaptability to dynamic environments. AI agents equipped with partial observation capabilities can adapt their strategies in real time as new information becomes available, ensuring they stay effective in dynamic environments. 5. Privacy preservation. Partial observations can be used to balance the need for data-driven decision-making with privacy concerns by allowing agents to make informed choices while limiting the amount of sensitive information exchanged or stored. Certainly, here are some disadvantages of searching with partial observations. 1. Increased complexity. Dealing with partial observations often introduces additional complexity to AI systems, requiring more sophisticated algorithms and computational resources for decision-making. 2. Risk of suboptimal decisions. Due to the uncertainty inherent in partial observations, AI agents may occasionally make suboptimal decisions, leading to less than ideal outcomes. 3. Difficulty in model training. Training AI models to effectively handle partial observations can be challenging, as it requires large amounts of diverse and representative data to learn accurate representations of uncertain environments. 4. Sensitivity to observation quality. The quality of observations directly impacts the performance of AI systems relying on partial information. Low quality or unreliable observations can lead to inaccurate beliefs and decisions. 5. Limited generalization. AI systems trained on specific partial observation scenarios may struggle to generalize their capabilities to new or unseen environments, potentially requiring retraining or fine-tuning for each new context. 6. Computational overhead. Performing inference and decision-making with partial observations often incurs higher computational overhead compared to scenarios with full observability, potentially limiting the scalability of AI systems in resource-constrained environments. Partial observations have various applications across different domains. 1. Robotics. In robotic systems, where sensors provide imperfect and incomplete information about the environment, partial observations are crucial for tasks such as localization, mapping, and navigation. 2. Autonomous vehicles. Autonomous vehicles rely on partial observations to make decisions in dynamic and uncertain traffic environments, considering factors like other vehicles, pedestrians, and road conditions. 3. Healthcare. In healthcare settings, partial observations are used in patient monitoring and diagnosis, where medical sensors provide incomplete or noisy data, requiring AI systems to make informed decisions based on uncertain information. 4. Finance in financial markets, where data is noisy and uncertain, partial observations are used in algorithmic trading and risk management to make decisions about buying, selling, or holding assets. 5. Natural language processing, NLP. In NLP applications, partial observations are used.